Hello, I'm Kiran Kumar from Nature of Physics. Today topic is ballistic pendulum. L is the length of the pendulum. Capital M is the mass of the block. O is the mean position. And here a bullet of mass small m moving with a velocity u collide the block. So the bullet and the block move with common velocity v raised to a height h at a position P represent extreme position and it is making an angle theta. Yes student, so that we can find cos theta is equal to L minus H divided by L. So total length is L and raised to a height H, remaining value is L minus H. So cos theta is equal to L by L is 1. So that rearranging the equation, so that we are getting height H is equal to L of 1 minus cos theta. And next two cases are there student. First case, let the bullet get aimed and block and the system raised to a height H student. Okay, and second case, if the bullet emergent out of the block with a velocity v dash, so that whenever the bullet is emergent, then before the collision momentum mu, which is equal to, after the collision individual velocities we are considering student, mv dash plus capital mv dash. Here initially only we have momentum for the bullet. After the collision, bullet and block both have the momentum student. Small m is the mass of the bullet, capital M is the mass of the block, and v double dash represent the velocity of the block and v dash represent the velocity of the bullet, clearly given with proof also student. Okay, v double dash, which is equal root over 2gh, is the velocity of the block. Next, case 1 derivation I'm going to explain. From the law of conservation of linear momentum, before the collision momentum is equal to after the collision momentum. Before the collision only bullet is in motion, block is at rest. That's why we can write m1 u1 plus m2 u2, which is equal to, this is inelastic collision because of after the collision both bodies move together, so m1 plus m2 of common velocity v taken student. Now according to this, here m1 mass is mass of the bullet taken as m student, and velocity of the bullet initially is u plus this capital M, and initially the block is at rest 0, which is equal to small m plus capital M into capital V student, and continuation there mu, which is equal to this value 0 into anything 0, small m plus capital M into V student. From this final velocity after the collision v, which is equal to mu divided by small m plus capital M. This is I can write as equation number 1 student. Then continuation, the kinetic energy of the system after the collision, the kinetic energy Ke, which is equal to half mv square. So kinetic energy which is equal to half m, velocity is v square student, but mass is sum of the mass of the bullet and the mass of the block student, clearly written small m plus capital M. Okay, now I can write this is equation number 2. And here kinetic energy convert into potential energy from mean position to extreme position. So potential energy at a highest point P, that is mgh, basic formula here, small m plus capital M into gh. I can write this is equation number 3 student. And law of conservation of energy, so initially the block and the bullet both have the kinetic energy, and kinetic energy convert into potential energy. According to law of conservation of energy, we can write kinetic energy which is equal to potential energy. So kinetic energy I can write of small m capital M v square, which is equal to potential energy small m capital M into GH, student. So this mass is get cancelled and 1 by 2 is cross multiplication, so that we will get V square is equal to GH. So V, which is equal to root over 2GH. Now I can write this is equation number 4, student, and H value replacing from this, so that velocity V is equal to root over 2G L into 1 minus cos theta. This is equation number 5. So that from equation number 1 we can write the initial velocity. So initial velocity U, which is equal to small m capital M into V divided by small m, student. I wrote from equation 1. See there clearly given, and here velocity values we have 2, so that 2 values are replacing, so that U, which is equal to m capital M divided by small m into V is equal root over 2GH. And next equation I can write initial velocity U, which is equal to small m plus capital M divided by small m into root over 2G. H value is L into 1 minus cos theta. Okay, student, this is equation number, I can write 6, and this is equation number 7. Different initial velocities and final velocities are completed, student. And continuation, there is a loss in kinetic energy of this system, that is initial kinetic energy minus final kinetic energy, delta Ke, which is equal to of m U square minus of m plus capital M into V square, student. So this is before the collision kinetic energy, and this is after the collision kinetic energy. Now here V value is replacing from equation number 1, student, so that delta Ke, which is equal to of m U square minus of m plus capital M, V square value is m square U square divided by small m plus capital M whole square, student. Okay, then continuation, this value and this power is get cancelled, and delta Ke, which is equal to of small m U square is common. Here one value is there, here also of m and U square common, so that there is small m and denominator is small m plus capital M, student. And continuation step, that is delta Ke, which is equal to of m U square LCM. So small m plus capital M minus small m divided by small m plus capital M. This small m and negative small m is get cancelled. So finally I am getting here delta Ke, loss in kinetic energy, which is equal to half into small m, and this is capital M numerator, denominator is small m plus capital M into U square. I can write this is equation number 8, student. Okay, this is clear information about the ballistic pendulum. Please do like and subscribe our channel Nature of Physics.